Hey everyone, I'm Toby at Humanitec, and today's video is all about secret stores. When you build your internal developer platform, you will inevitably need to handle secrets. There may be database credentials or certificates that your workloads need to access the systems around them. And many organizations will be using a secret store of some kind to properly safeguard and manage their secrets. Popular offerings include HashiCorp Vault, Azure Key Vault, Google Secrets Manager, or AWS Secret Manager. Today's examples will be based on Google Cloud, but will keep the product specifics to a minimum and instead focus on how to connect your secret store and how to use it for your workloads with the Humanitec products, which works just the same for all store flavors. So without further ado, let's get started by looking at the big picture first. When you use the Humanitec products, you will have the Platform Orchestrator at the center of your internal developer platform. So here's the Platform Orchestrator right there. And from a high-level view, you will have developers using the Platform Orchestrator to deploy their workloads. So here's a developer person, and developers will usually write a score file to describe their workload and deploy it to the Platform Orchestrator. Now what happens is that the Platform Orchestrator analyzes that score file, resolves all the dependencies, and creates all the objects that are needed to actually deploy that workload to a Kubernetes cluster. So there's a cluster over here. And by default, when you start out with the orchestrator, what it does is it creates all of the Kubernetes manifests that it needs and deploys them straight to the cluster. So those are deployments. Those can also be secret objects because by default, the Platform Orchestrator has access to a Humanitec hosted secret store. The secret store is being used when nothing else is configured. And when your workload descriptions reference any secrets, the secrets are written to and read from that Humanitec secret store. So you will have those secret parts in here as part of your manifest, and you will have Kubernetes secret objects created for you. Now, as an organization trying to achieve a higher security posture, that's not what you want. You will want to have that secret store managed by yourself and be part of your own infrastructure. So you want to have the secret store within your boundaries, within your private network, and managed by you, right? So when you have that, this direct deployment is not going to work because the Platform Orchestrator will not have access to that secret store as it should be. What you then can do is install the Humanitec Operator onto your cluster. The operator is just a simple Helm deployment. It runs as a pod on your cluster. And what it does is it watches out for specific objects that are being created by the Platform Orchestrator. Because when the Platform Orchestrator knows that there's an operator out there, and we'll get to that in a minute, instead of creating the entire Kubernetes manifest, it will instead create a set of Kubernetes custom resources. Those custom resources are sort of the pre-rendered version of all the things that are eventually supposed to be there without including the secrets. So those are just the non-secret parts of the structure. And what the operator then does is when we connect it to the secret store, it can take those custom resources and take those secrets and combine the two and again deploy the full-fledged manifest that we need, right? So that's the Platform Orchestrator in so-called operator mode. The operator mode is activated whenever there is an external secret store configured as the so-called primary store for the orchestrator. That's when it knows, okay, there's an operator out there. I'm not supposed to be using our internal secret store. I'm supposed to be writing those custom resources instead. Okay, cool. Way to go. There can be more than one secret store too. So if you have more than one in your infrastructure, there's another secret store out here. And you can connect them to the same cluster or to different clusters any way you want, and then reference them in your workloads. Because what you do is, through the setup that we're going to look at in a minute, what you're going to do is that those custom resources, instead of containing the secret values themselves, they will create so-called secret references. Those secret references point to a particular secret store and reference a particular secret, so that then the operator can take that reference, resolve it by reading the value from the secret store and creating the full-fledged manifests at the end. Okay, splendid. So that's basically how it works. If you want to connect your secret store, there's instructions on how to do that on the developer documentation that we provide. Currently, we do have versions out there for Google Secret Manager and HashiCorp Vault. We are preparing pages on Azure Key Vault and AWS Secret Manager as well, which are coming up soon and which will look very similar. Let's quickly look at the prerequisites that we have to connect a Google Cloud Secret Manager. I promise that we're not going to go into the detail of that particular type of store, but two things are worth pointing out. For one, you need to have determined the required access level with Secret Store for the Platform Orchestrator and the Humanitec Operator, respectively. Access levels meaning either read, write, or no access. What does that mean? Go back to our picture really quick. So, our operator obviously needs read access to the secret store because it needs to read those secrets to resolve the secret references, right? It also needs write access to one of the secret stores because it needs to store some state in between deployments that it needs to maintain its operations. The state is called resource cookies. I'm going to draw a little cookie type thing up here. And it needs to store that state somewhere. And that's what we define the so-called default store for. So one of the stores that's known to the operator has to be the default store to store those resource cookies, and it needs to have a write access to that store to write and read those cookies. It's sufficient to have read access to any other store it might be connected to. Now, the Platform Orchestrator does not really need any access to any secret store. All it needs to know that there are secret stores out there and know their ID. There is the option to allow your developers to write secrets through the Platform Orchestrator into one of the secret stores, which is the primary, right? So the primary way up here can optionally be used to directly write secrets that you enter as part of API requests, resource definitions, shared values, etc., through the Platform Orchestrator. And in that case, the orchestrator needs write access to the secret store. It's write access only, not read, because the Platform Orchestrator will never return any secret values through its API or UI. Write access only, or no access if you don't want to provide that capability. That's basically your choice. So that's one of the things worth looking at. And the other thing, besides all the Google-specific setup aspects, are you have reviewed the implications of switching to operator mode. Now, what does that mean? If you have been using the Platform Orchestrator in the standard direct cluster mode before, so you have been deploying Kubernetes manifest to the cluster, then you might have been using the Humanitec secret store, which still exists, right? It's still here, and it might contain secrets that you have been writing into that Humanitec secret store. And access to those secrets will basically be lost as soon as you switch over to operator mode. There's something just to be aware of when you switch over. Probably not a big deal if you're doing it straight away from the start, but just to be something to be aware of. Cool, fantastic. So let's get going. Let's actually connect a store. So we have a Google Secret Manager set up right here. This is what it looks like. It's pretty empty right now. There's just one dummy secret in there, nothing else. If I refresh the page, there's no further secret. So let's get started by connecting that secret store to both the Platform Orchestrator and the Humanitec Operator on the cluster side. So let's now register the secret store with the Platform Orchestrator first. We do that by submitting a really quick API call to the secret store's API. And it defines a new secret store. And it's really very, very simple. The store is just defined by a secret store ID, which is defined in this environment variable. It's a GCP type store. The exact configuration values obviously vary a little bit depending on the type of store you are using. For GSM, it's really, really simple. It's just a project ID and nothing more, because anything else is handled through the workload identity that's set up on the cluster. Again, I don't want to bore you with the Google specific details, but that's basically how it works. So we can submit that, and we have our secret store registered with the Platform Orchestrator. Fantastic. Second step is to register it with the operator. That's the other side of the game. So let's register it with the operator. Registration on the operator means creating a Kubernetes custom resource of type secret store. That's one of the custom resource definitions that comes with the Humanitec Operator installation. So here's a secret store. And again, it's very, very simple. It just has an ID. Says, okay, I am the default. Remember, we mentioned the default. I'm going to write resource cookies into this store, and please use the secret manager API of this project, and that's about it. And off you go. And we now have the secret store created. Fantastic. And this is basically it. That's the two things you need to do. We now have created links for both the operator and the Platform Orchestrator to our secret store. So we are now basically ready to go. So let's test our setup by actually deploying an application and seeing if we can reference secrets. Let's start by creating some secrets, because our secret store is still very, very empty. So let's change that and just create a bunch of sample secrets. And do that through the Google Cloud API. So this is using the gcloud secrets create CLI command. This creates a secret called mySQLUsername in our GSM project, and its value is super secret username. Fantastic. So let's create that. And let's create two more because we're going to need them. We're also going to create a super secret MySQL password and a secret shared value. So here's our MySQL password, value is super secret password, and here's my shared value, and the value is my super secret shared value. Let's create those two and have a look at the Google Secret Manager UI. Refresh that and see if something shows up. It does. So here's our 3 new secrets that we just created. Fantastic. Great. So now our secret maintainers up here. They haven't been in the picture, but they're obviously very important. There's someone up here maintaining your secrets, right? Someone has to write and maintain your secrets in your organization. Just going to call them a secret maintainer. And they are writing and maintaining secrets in that store, which we have just done. Great. So let's deploy an application. Let's switch sides and become the application developer and deploy a score file. We have prepared one, so let's look at it real quick. So here's a score file. It's very simple. It uses a standard busybox container, and all it does is print its set of environment variables out to standard out every 60 seconds. What we've done here is to define 3 variables for our container. Those 3 variables reference resources that we have in our score file. So we have a secret shared value that references the env resource and the value which is called my secret shared value. That's our env resource right here. So somehow there has to be a shared value of that name in our environment that we're going to deploy into. Likewise, we reference 2 other resources, actually 2 other values out of the same resource, which are going to be a MySQL username and a MySQL password, which are down here. And then we are going to mysteriously request a 3rd type of resource, which we call myConfig, which is not referenced in the workload, but is still going to do fulfill a certain purpose, which we're going to see in a minute. So this is my score file. We are requesting a MySQL database, we're requesting a configuration object, and we are always in some environment. So let's prepare this deployment and make sure that these resources can actually be created. Let's start out with the first resource that we're going to define in the Platform Orchestrator by creating a resource definition. So here's our first resource definition, which is our MySQL database. It's not a real MySQL database. We sort of emulate one. We emulate it by using the so-called Humanitec Echo driver. So it's a MySQL type resource, but the driver type is Humanitec Echo, which means that it's not a real resource that's going to be provisioned. It just behaves like one, right? Sort of emulates a real MySQL database. It has the same inputs and outputs. And some of them are just hard-coded. They are not secret. They sort of represent the access data for this database. And down here, it gets more interesting. Those are our secret references that we keep talking about, right? Here's our username and password secret refs. There's 2 secret refs, and each secret ref is very, very simple. It references the store and the key of the secret inside that store. So this just says our username lives in that store and is called MySQL username, and our password lives in that same store and is called MySQL password. Please, dear Platform Orchestrator, make sure that this is resolved at runtime into the actual secrets from that store. There's also, I almost forgot, there's also matching criteria down here, which will make sure that this resource definition will be matched to the application we're going to deploy into, which is very important. So let's create this first resource definition. Fantastic. Let's create another one. I mentioned, as you recall, this config type resource down here. I said, what's this? Well, excuse me. What's this mystery config resource down here? This config type resource is sort of a vehicle for us to demonstrate the behavior of the resource cookies. Remember, the resource cookies are those little pieces of state that the operator needs to store in the secret store in between invocations. And we're gonna play a little trick and create a almost fake resource which has the sole purpose of writing a resource cookie into the store and does nothing else. And we do that by using a type config resource, which is the one that we requested in the score file, using the driver type template, which can just be used to render any sort of content and execute it on the cluster. It's not actually doing that, but it has a cookie template, and the cookie template is just a static string, which is called my demo resource cookie. And it's also matched to our application app ID. So whenever a resource is going to be created according to this resource definition, it's going to be instantiated, and it's supposed to write a resource cookie with that value into its default secret store. Fantastic. Great. So there's two resource definitions that we now created. And let's really quickly look at our Platform Orchestrator. In the resource management, we see, okay, here's the cookie config that we just created, and here's our icon MySQL. So they're both now available. Fantastic. What we still need is an application to deploy into. So let's super quickly create a new application. We can do that using the UI, or again through an API call. I'm going to create a new application. It's going to be called My App. Very innovative. Excuse me. This My App application will also have a default environment of type development and the name development. So we'll go to our Platform Orchestrator super quickly. We'll see this My App application has been created. And here's a development environment, but it's empty. We haven't deployed into it yet, but we will in a minute. Before we do that, there's one last thing to do. Remember, in our score file, we had that shared value that we want to access. This secret shared value, which references the environment. That doesn't exist yet, and that's what we have to define. So we're now going to define a secret shared value for our application, which is also using a secret reference to resolve to the real value. Again, we're going to do that through the API. And in case I hadn't mentioned it, all of these commands are contained in the documentation that I just showed you. You don't have to memorize anything. There's no separate cheat sheet. So all of the commands are in the documentation for you to reference and replay at any point in time later on. So let's create this shared value in our application. It's called my secret shared value. And again, it consists of a secret reference which points to a secret store and a reference named my secret shared value. So our application My App now has this shared value that it provides to all of its environments that applications are going to be deployed into. Now we can see it right here. Here's our My App application, and here's my secret shared value and the various and secrets, and it can be referenced by our applications. And our score file, one more time, is doing just that. Here's our environment type, resource, and here's the reference to the secret shared value. Fantastic. So we should now be all set to actually deploy our application. One last thing to do is to make sure that it's going to be deployed to the right Kubernetes cluster. Let's go back to our Platform Orchestrator super quickly and check our clusters we want to deploy to our Google Cloud cluster. So that's the one down here, the GKE Dev. And its matching criteria do not yet match the My App application. So we're going to add that real quick using another API call. We can use it. We could do it through the UI as well. So we're going to create that matching criteria, memorize its ID for later, And if we go back to this view, refresh it real quick, here's a new matching criteria. So now our application, my app, will match this Kubernetes cluster whenever it's going to be deployed to a development environment. Fantastic. Great. So we have our resource definitions in place, our core file is in place, we have our cluster set up, so we are now all ready to deploy our application. Let's do that and actually deploy our core file using just one invocation. Great. So we're going to use the core Humanitec CLI tool. I'm going to use core Humanitec delta -- deploy, give it the core file, give it the target application and environment, the target org, and the token for authorization, and we're good to go. Great. So deployment has been submitted. Let's go back to our Platform Orchestrator super quickly and check the development environment of my application. And we now have a running deployment in our development environment. If we click in here, we see our workload, and it claims that there's one pod running on our cluster. Fantastic. So let's have a look. First thing we're going to do is find out which namespace our application was deployed into. By default, if you don't set up anything in particular, the operator will create a namespace that's just named after your UID. You can change that, you can give it a proper name, but for the sake of this example, we're going to keep it really, really simple. So this is the app namespace that our application with the label app ID my app was deployed into. So let's look if there's a pod running. So kubectl get pods, and we're going to use the app namespace, and here's our pod running. Fantastic. Great, so that appears to have worked. Let's look at some of the intermediate objects that were created, just for the sake of interest. Remember, we said that there are a bunch of custom resources that were created as part of the operator being active, right? So there's our custom resources down here. And just for the sake of interest, let's look at some of these custom resources. So one of them is the workload. So we're going to look into the app namespace and see if there's a workload in here and what its status is. And it says, okay, we have a workload and it's rollout and it's ready. Fantastic. So that's the actual workload, or the object that represents the actual workload being rolled out. There's also a bunch of resources that have been provisioned. Remember, we requested a MySQL and a config, and they should all be here, which they are. So there's the my app module, and there's also the myconfig resource, which is provisioned, and the MySQL resource, which is also provisioned. So those are two other examples of those custom resources we've been talking about. And last but not least, there's a so-called secret mapping object that has been created. The secret mapping object maps the resource, maps the secret references to the actual Kubernetes secret objects that have to be created by the Humantec operator on the cluster. So there's a secret mapping object right here, and it says secret applied, and we should now see an actual secret in here. So let's look at the secrets. There you go. There's 3 of them. 1 is empty, 2 actually have data, and those 2 other ones we're interested in. There's a resource secret with 2 data items. Those are the MySQL username and the MySQL password values that have been placed in that secret. And there's another secret called shared secrets in here. This secret contains the application shared value that we also provided, which is placed in this Kubernetes secret. Great, so let's have a look at them. Let's start with that config secret. Remember, this is the secret that represented that secret, that resource cookie that we're supposed to write into the secret store. So we would now expect to find a new secret in that store, which represents one of these cookie objects up here, right? So let's look at the store and see if that is the case. If I refresh the view, we do indeed see a new secret which just appeared. We didn't put it there, the Humantec Operator did. So this is the resource cookie. It's named after the resource and its ID that was assigned to it. And if we look at the value, it's a base64 encoded string. Let's just decode that real quick and see if it's the string that we're expecting. And it's my demo resource cookie, which is just the string that we defined in that resource definition for that config type resource. So check, we have just proven that the write access works for our Humanitec Operator to the secret store, which is part one. And finally, we're going to look at the logs of our pod. Remember that pod was supposed to print all of its environment variables every 60 seconds. So let's just look at its logs super quickly and grab for the things we are interested in. And we see that indeed in those logs we find the MySQL password, the secret shared value, and the MySQL username, which have been read by the platform, by the operator, placed in the Kubernetes secrets and mapped into the Kubernetes pod using standard Kubernetes mechanisms. Fantastic. So that proves that read access for the operator to our secret store also works. So write access worked, which was the way up, and read access worked, which was the way down. Splendid. So that about closes and completes the example. Let's recap real quick. What did we do? We had our core file to the left. So here's our core file. And we deployed that via the Platform Orchestrator to the cluster. What we also did was reference some resources in our core file. So we had a bunch of resource definitions that we had to set up first, right? So here's a resource definition for our MySQL database, and that contained a secret reference, actually 2 of them. So here's a secret ref, that was the MySQL username, MySQL password. Same thing for that config resource, another resource definition with a secret reference. And we also had an application shared value, which also contained a secret reference. So here's a shared value with a secret ref. And those were referenced by our core file and became part of the deployment, right? So all those put together, taken by the Platform Orchestrator, deployment took place to our cluster, custom resources were created, the operator picked them up, read secrets from the secret store, and was able to create the final Kubernetes manifest. Very colorful picture, but that's how it works. The great thing is that for our application developers, nothing changes. This core file back here does not change. This core file does not know anything about secret references. This core file does not know anything about secret stores. all your application developers continue to do is request resources of a certain type, and they don't have to know and they don't have to care where any of those secrets are maintained. They just say, hey, I want my MySQL, I want my config, I want my resource of type X and Y. And the platform engineers, through setting up those resource definitions, hooking up the secret stores to the Humanitec components, they make sure that all of those dependencies can be resolved. But for our application developers, life does not change. And that was it. Thanks for watching. Like I said, all of the information that you just saw is contained in our docs, in our how-to guides, and in the testing page, which is up here, which guides you through the same process that we just went through. If you want to repeat it or look up some of those examples that we used, it's all in here. And that was it. Thanks for watching. I hope that was useful. Until next time, take care.